You can't get all the way to Mars without fuel, and a lot of it. Chemical propulsion has been the standard for spaceflight for decades. But if humans are to travel to Mars, they need a propulsion technology much more powerful. When you get into needing the level of power it takes to advance our exploration of the moon and send humans to Mars, the only way to do it is nuclear power, said Rob Chambers, Director of Commercial Civil Space Strategy and Business Development at Lockheed Martin. If you want to be able to explore cost effectively, be Earth independent, and make going to Mars feasible, you need nuclear systems. NASA has signed an agreement with the U.S. Defense Advanced Research Projects Agency, or DARPA, to develop a nuclear rocket that could shorten travel time to Mars by about one quarter compared to traditional chemical rockets. But before nuclear technology is launched into space, there are risks that need to be addressed to ensure public safety. NASA and the U.S. Defense Advanced Research Projects Agency, or DARPA, plan to test a nuclear powered rocket engine in space as early as 2027, potentially revolutionizing how people travel to the cosmos in the coming decades. The two agencies will work on a nuclear thermal propulsion system, a technology NASA wants to use to send humans to Mars in the late 2030s. But the test mission, known as Demonstration Rocket for Agile Cislunar Operations or the DRACO program, would not involve astronauts. Advocates of nuclear powered rockets have long stressed the advantages, allowing spacecraft to travel faster, carry heavier loads of people and cargo, and use fuel more efficiently than the chemical based rockets of today. Lately, the idea has galvanized, with 110 million budgeted for the project this year. It's not clear how much everyday people know about the technology and whether the project will renew concerns about nuclear disasters. NASA and defense leaders say that the rocket will be safe for people on the ground, as well as eventually make space travel safer for astronauts. Faster trips mean they'll have less exposure to harmful cosmic rays. But at the American Institute of Aeronautics and Astronautics Conference, where the new collaboration was announced in Washington, D.C., the moderated have spoken for the collective conscience when he said, obviously, the public is going to say, you're going to put a reactor over my head? Nuclear rockets are not a new idea. Experiments were conducted in the 1950s by the US military and later NASA, but never put it into space. Now, with the prospect of sending humans to Mars in the 2030s, the idea is being revived in an effort to shorten the roughly 7 months it takes a conventional rocket to get to Mars. This might be a boon for future astronauts who face a 7 month one way journey using current technology. The idea is to use a small fission reactor to heat up a liquid fuel to very high temperatures, turning it into a hot gas that would shoot out a rocket nozzle at high velocity, providing thrust. The design of a nuclear rocket means they typically would produce less thrust than a chemical rocket. But nuclear engines could run continuously for weeks, constantly accelerating, ultimately reaching higher velocities in a tortoise and hare kind of way. We are putting radioactive materials into space, but we have designed the entire process to be safe, said Stephanie Tompkins, director of the Defense Advanced Research Projects Agency, the research and development arm of the military, which is leading the overall program. Part of the reason for doing it in space in a lot of ways is that it's safer than having to do it on Earth. How would nuclear rockets change space travel? Experts describe nuclear powered rockets to Mashable as being a leap ahead technology, on the level of horse and buggy stagecoach to steam locomotive, or landline telephone to smartphone. Right now, engineers rely on swinging around planets to get gravity boosts, the extra oomph needed to send space probes deep into our solar system. But nuclear power would free missions of having to wait sometimes years for the correct timing of orbits. You're opening up the outer solar system to scientific exploration. You don't have to wait for the planets to align. You'll have launch opportunities every year, said Dale Thomas, Deputy Director of the University of Alabama in Huntsville Propulsion Research Center. And by the way, since we're talking about direct trajectories, you get there in about half the time. With nuclear thermal propulsion, getting to Mars could take as little as 2 months instead of 9, depending on the path taken, engineers said. And reducing the trip time would have the advantage of limiting the supplies needed for such a journey. Why did the US stop testing nuclear rockets? The United States' last nuclear thermal rocket engine tests happened more than 50 years ago. During that time, the Los Alamos National Laboratory in New Mexico helped build nuclear rockets for NASA's Project Rover program. The program ended in 1972 when President Richard Nixon made the political decision to cut funding for human missions to Mars and instead focus spending on the space shuttle and research in low Earth orbit. A nuclear thermal propulsion system would pump liquid hydrogen through a reactor, where uranium atoms would split apart and release heat. This process, known as fission, would convert the hydrogen into a gas and eject it through a nozzle, creating thrust to propel a spaceship. The game changer in developing the technology today is a new form of uranium, which is not considered a weapons grade material. That opens the door for commercial space companies to work on spin offs after the mission, said Pam Melroy, NASA's deputy administrator. But this low enriched uranium poses one of the biggest challenges for NASA. Materials in direct contact with the reactor fuel have to withstand over 4,000 degrees Fahrenheit, about half the temperature of the sun's surface. Why NTP, or nuclear thermal propulsion? In short, speed, efficiency, and reusability. NTP will enable faster space travel than ever before. Increased speed from NTP means benefits like longer launch windows, less crew exposure to cosmic radiation in space, and satellites and robotic spacecraft getting to their destinations quicker or with much higher mass. The speed of NTP comes from its high efficiency thrust, upwards of 2 times more efficient than conventional propulsion systems. It could take 100 launches to get humans to Mars on a chemical propulsion system, but we can get it down to 5 with a nuclear thermal propulsion system, said Chambers. NTP's efficiency can also enable more abort options during missions. Other benefits include maximum reusability and extensibility to other missions. NTP allows the use of fewer refuelers than other systems, making it environmentally cleaner, more efficient way to fuel. If we want to get serious about deep space exploration, a reusable nuclear system is a cleaner, more efficient way to achieve our goals, said Bendel. NTP will enable us to extend our exploration beyond the moon more quickly than other alternatives might. Are nuclear powered rockets safe? In terms of safety, engineers say the nuclear systems would not be used at the launch pad at all. In fact, that's one of the most common misconceptions about the technology. In sort of a hybrid approach, chemical rockets would get the spacecraft off the ground. Then, once the ship had climbed to an altitude in space between 400 to 1,300 miles, well above the International Space Station, the nuclear powered engines would take over. That's critical to ensure the material is no longer radioactive by the time it re enters Earth's atmosphere, Mallory said. If, for some reason, the chemical rocket blows up and the nuclear powered engine ends up in the ocean, the nuclear hardware still can't go critical, Thomas said. The in space rocket system doesn't work until it reaches orbit. Perhaps the greatest safety risks come into play during ground testing, a crucial step before launch. Engineers will need huge facilities that don't exist yet to capture the exhaust, a recommendation that came out in a 2021 independent report NASA had requested from national academies to study nuclear propulsion. New construction or modifications to existing facilities could cost billions of dollars. Safe testing facilities are a consideration that didn't happen decades ago when engineers were working on earlier versions of these systems, said Roger Myers, an aerospace consultant who co chaired the National Academy's study.